Hey guys, how's it going? So today we're going to be talking about entity component systems and its architecture, commonly known as ECS. ECS is generally found in lots of different game engines, and the reason for that is because it improves code flexibility and also memory efficiency in the way that it accesses data. The plan is that by the end of this video, hopefully you'll have an understanding of ECS and its architecture and why it's beneficial, but also you'll know the fundamental building blocks required so that we can then implement our own ECS together. It's important to note though that ECS isn't necessarily suitable for every game that you make, and the reason for that is that it adds complexity to your code base. So make sure you understand the fundamentals and then you can make an informed decision for your game or game engine. Let's take a look at the details. First up, entities. Think of an entity as a general purpose object, but with a twist. It's super lightweight. An entity isn't much on its own. It's essentially just an ID, a unique identifier that the ECS world can understand. Think of this as an entity. I'm going to show it as a circle, but really it's just a unique identifier, an integer. In a game, anything can be an entity: a player, an enemy, a rock, a tree, even a bullet. The beauty of entities in ECS is their simplicity, acting as a container to add components onto, turning this unique identifier into something meaningful. Next, we have components. Components are pure data. They are attributes that define the aspects of entities. For example, imagine that entity that we had before, but now with a position component, and also a health component. These are things that we can add to our entities to describe them in the game world. By separating data from logic, components are reusable and interchangeable, making the code cleaner and much more modular. Components provide us this amazing amount of flexibility because we can now add different components to entities to create what we'd like. For example, if we're creating an enemy player and we want it to have a health bar, we add a health bar component. Or if we want to add a collision box, we add a collision box component. Or if we want to add a mesh renderer component, then we add a mesh renderer component. You see where I'm getting at? These are all things that make ECS really flexible for the developer. And finally, systems. The brains of the operation. Systems perform actions on entities with specific sets of components. And this is where all of the logic lives. Take, for example, a movement system. A movement system might be interested in all entities with a position component and a velocity component. And then it will update each entity's position component based on their velocities. Systems work on batches of components. And this is why earlier I mentioned about the memory and performance benefits of ECS. And that's because ECS organizes its logic around the data it acts upon. Let's dive a little bit deeper into that performance and memory benefit that I mentioned earlier. At the heart of ECS's performance benefits is something seemingly simple, yet really powerful, and that's storing components in contiguous arrays. But what does that mean, and why does it matter so much? Okay, so imagine you're at a supermarket, and this is you. And on your shopping list you have some vegetables, some milk, some bread, and to get all of that stuff you have to kind of go walk around the shop and find everything that you need. And this might be an example of a route that you would take. And then you're going to exit. And this isn't very efficient, right? And it's quite annoying because you've got to bounce back and forth between the shop to get what you want. So imagine now if this was your supermarket. And here you are at the beginning of the shop. And instead, all you have to do is you have to go down this one aisle. And you can pick up everything that you need right next to each other in one straight line and smooth journey. And then you're out of there. And this is effectively the essence of storing components in contiguous arrays in memory. And if we imagine this as an array, we have all of our related data, for example, our grocery list, next to each other in memory. And we can do the very similar things with, for example, position or health or velocity of game entities by putting them in memory next to each other. So why is this continuity in memory such a big deal? Why can't CPUs just access memory whenever they need it? Well, they can, and they do. But CPUs love efficiency, just like you love the idea of 1 hour shopping. CPUs are designed to grab chunks of data from memory to work on, but they're also designed to predict what memory you might want next. And this works especially well if you're accessing data in a predictable fashion. With ECS, because we store components in contiguous arrays and we iterate over them in a sequential predictable fashion, when the CPU goes to pick up one component, it can then also prefetch adjacent components into its cache, and this significantly reduces the time that we spend fetching data. Okay, so if we go back to the analogy that we had before, You're in the supermarket and you've got yourself a basket. And in that basket, you're going to put your stuff that you want to buy. And first of all, you're going to go to your aisle and you're going to say, I want some bread. And the supermarket is going to predict what you want next. And it might say, well, they wanted some bread, and next in the aisle was some milk. So I'm going to put that in their basket. And then also, next in the aisle, again, was some vegetables. So I'm going to put that in their basket. And this is effectively how CPUs prefetch and cache. And we can think of your basket as the CPU's cache. So what it will do is, when you go and grab the bread, it will say, well, I'm going to bring some other things back with me whilst I'm also here. And it may be the user, you or the developer, will also want that memory. And if so, it will hit that memory in its cache, and it will spend a lot less time fetching data. This is caching and prefetching in action. The CPU predicts the memory that it's going to need next and puts it into its cache, and this significantly reduces the time that we spend fetching data. So how does this compare to traditional object-oriented approaches? Well, let's draw it out and see what that might look like. So let's compare to a more traditional object-oriented approach, and if we use the same analogy of shops in a shopping centre, we could think of each of these shops as an object, each encapsulating its own data and its own behaviour. Now, for us, this is super convenient because logically it makes sense as a developer, but what it's actually doing is making the CPU's job a lot harder. For example, if we try and do our shopping again with our shopping list, we want to go and grab our vegetables, we have to go here. And then if we want to go and grab our milk, we have to go over here. And if we want to grab our bread, we have to go over here. And this is what the CPU has to do if it wants to grab this specific type of data. It has to do a lot of jumping around. But also what it does is it makes it really difficult for the CPU to predict what you might want next. For example, when we went to get our broccoli here, the CPU might think, well, okay, I'm going to load this data next into the cache as well whilst I'm here. And whilst it does that, you didn't actually want this data at all. You wanted this data. And therefore, it was completely useless at doing this. And then when you went to go and get the milk, it might say, okay, well, I'm going to predict that they might want this next. So it grabs this data as well. But again, this is completely wrong because really you wanted this data. And if you see what I'm saying here, we're actually making the CPU, we're not utilizing the CPU's design of prefetching and caching the data that we might use. So it has to do a lot more work. And this is what we call cache misses. If you're interested in kind of cache misses and the behaviors and mechanics of CPUs, then I'll link a video by a guy called Simon Dev who explains this stuff really well. ECS represents more than just an architectural choice. It's a paradigm shift. By decoupling data from the behavior, ECS provides unparalleled flexibility in game development. It allows developers to add, remove, or modify existing entities without the headache of digging through tangled object hierarchies. And there you have it, the basics of ECS. I hope you have an understanding of the basic building blocks of ECS and also the underlying fundamental reasons behind the performance benefits of ECS. In the next episode, we'll be writing our own ECS in C++, so I'd love it if you liked and subscribed to join me next time. I'd also love to hear your thoughts and questions about ECS, so if you do have any, then put some in the comments below. And finally, thank you very much for listening. This has been Dan, and I'll see you next time.